All right, we're going to pick up where we left off talking about t-tests. And last time we were talking about independent t-tests, and where basically you're getting two means from kind of two different samples, even though it's from the same category, such as gender, males and females, or we talked about Greek affiliated and non-Greek affiliated, came from same sample. It's called independent t-test. This one is we're going to look at now is called a dependent t-test, and that's if you want to compare a person, or again two samples that are related. So in this case, the sample is related because it's coming from the same person. All right. So looking at this, it's commonly used for pre and post tests. So when we do for RSM, for example, when you came into the program in 242, you took the pre-test, and then when you, last semester, most of you were in 396, and you did the post-test. And so what we did was we run a dependent sample t-test, and we compare, see if there's a difference in the means and basically your scores from the first test and the second test. Obviously, we want to see a significant difference, but it gives us a way to measure that. So other areas, for example, that you might use it, an effective marketing campaign. How many tickets did you buy prior to the marketing campaign? We put a new marketing campaign in place. Do we see an increase after that marketing plan happening? Okay. Again, there's ways that we can go about looking at that pre and post test. You might do it in exercise science. You might do it in some other program, just to kind of get a here's where they were at the beginning, here's where they were at the end, and we can see if there's a statistically significant difference between those scores. Okay. The independent sample t-test, again, that's one that's widely used. It compares the difference between two separate groups. Okay. And the groups are usually randomly assigned. For example, in exercise science, we might put part of the sample into the test category and or the treatment category, and part of them in the control category, and then we can do a pre-test or a test at the end to see if there's a difference between sample 1 and sample 2, the control group and the treatment group. And what's the difference between the two? Well, whatever that treatment was, and we're seeing if that treatment might have an impact. Okay. But we're basically looking to see if there's a difference in the means between the two groups. Okay. And it can be done naturally in naturally occurring groups like gender, males and females, and interest in buying tickets, or Greek and non-Greek buying or gambling. My dissertation was on college athletes and college student athletes and non-student athletes, and see if there was a difference between the gambling rates there as well. And so, or rates as well as scores on the South Oaks gambling screen, we could do t-tests and see if there is a difference in the means there. Okay. Building off of t-tests. So t-tests, you're comparing basically two means. What happens if you have more than two means? So more than two categories within a variable that you want to look at. That's where we get into an analysis of variance. Analysis of variance, or you'll see it referred to as ANOVAs, is, all right, we can't run a t-test because we have more than two categories. Now we need to run an analysis of variance because we're going to have more means to compare, right? So it measures the differences in means on a dependent population based upon different variables that you have. Okay. Similar to t-test, but t-test only does two categories within a variable. A analysis variance give you the opportunity to do more than two. Okay. Again, okay. So looking at this, income difference on tickets bought. So let's say one of the variables that we want to look at is income, family income or income of the individual, based and see if there's a difference in the people, how many tickets people buy, and see if income really has an impact on the number of tickets, right? So we can look at a running ANOVA to see what the mean of each category of family income and how many tickets they buy. Okay. Now think of family income would have to be put in ranges. So think of it as, a family income of between 0 and 10,000, dollars to 50,000, 50,001 to 100,000, and go up. And you can break it down however you want, but it puts people in categories. And if you have more than 2 categories there, then you average up how many tickets everybody buys in each of those categories, and then you can see if there's a difference in those means there, okay, and the number of tickets that people purchased. Okay? And that's what ANOVA does. T-test, we couldn't do that. We'd be comparing each group individually, and it hinders the effectiveness of the test. So here we're just doing it all in one test, okay, to see if there's a statistically significant difference. So ANOVA, T-test, we're comparing means. Okay. Correlation now, on the other hand, is a little bit different. Correlation is going to tell us the amount of association, or a measure of association between 2 numerical values or variables. Okay. So one of the things we might look at, let's say something simple, is there a correlation? Is there an association between the amount of the temperature in the summer and how much water people drink? Okay, so we're looking at 2 variables: temperature of the outside temperature and how much water somebody drinks, and we're using that as a measure of thirstiness, or how thirsty people are. Okay, so ideally our hypothesis would be, as the temperature goes up, people's thirst go up. Okay, and we'll see if there's any correlation there with this one. Okay, so for 7 random summer days, a person recorded temperature and their water consumption during a 3-hour period which they spent outside. And let's say they get results that look something like this. I'm going to have to move me down here. So the temperature of the first day was 75 degrees. They drank 16 ounces of water. Then the temperature next time they measured was 83, 20 ounces. 85, temperature, 25 ounces. And it works its way down to 99 degrees outside, and they drank 48 ounces of water. Okay, so just looking at it, it looks like as the temperature goes up, what happens? The amount of water they drink also goes up and reaches that point about 97, where it kind of leveled off at 48 ounces of water. Okay, all right, so what's that mean? Well, what we can do is actually run a test to see if there is a correlation, there is an association there, and kind of what it looks like. So what a correlation tries to do is it looks for a linear relationship. Okay, a linear relationship. Linear means a line. So if you look at this, and we plotted the findings on a graph here, and here's each of the measures. So 75 degrees, and we drank 16 ounces of water, and it works its way up. Here's the 99, 97, where they drank 48 ounces of water. But what does that look like? If you looked at those dots, what's it look like? Well, you can, if you use your imagination, I know it's not perfect, you could kind of go through and draw a line there that would be, all those dots would be pretty close to that line. Okay, that's what a correlation looks for. Is there a linear relationship there? Can we see a line based upon plotting out all those points? Okay, and one of the things to keep in mind, so if in this case, again, you can see a line. It's not perfect, but you can see a line here. But what happens is this x-axis and the y-axis, as the x-axis numbers increase and the y-axis numbers increase, okay, that's called a positive relationship. So as usually they start out lower here on the left, and they get higher as you move to the right. That's a positive relationship. Okay, so it's a positive, like the water example and the heat. As the heat goes up, the x-axis, so does the amount of water people drink, and that was the y-axis, okay? That's positive correlation. On the other side, you might run into a negative correlation. Negative correlation just means that as one goes up, the other goes down. Can you think of something that maybe in our field, as one of the values goes up, the other one goes down? Well, let's look at it like this way. Let's say, Coastal's football ticket prices are fairly low. Let's say, we try to plot them on this graph. Let me find my. So let's say we plot them here. This first one we sold the tickets for, I don't know, $5, and we sold a whole heck of a lot of tickets there for $5. Okay, we even bumped it up to $5 or $7, and they still went up a little bit. But then as we raise the price and keep raising it out to the right, you see the amount of tickets that we sell goes down. That's what we call a negative correlation. One of them is going up. In this case, the ticket price on the x-axis is going up, and the amount of tickets that people are buying are going down. It's a negative correlation. Okay. The word of the day for this video is head. So the fourth word is head, H-E-A-D, and again, hopefully you're keeping track and putting these all together in a sentence so that you can do well in that last case study. Okay, so the word for this video is head. Okay, so one thing to keep in mind with correlations, correlation scores are only going to range from -1 to 1. So 1 is a perfectly linear relationship. When 1 moves up, the x-axis moves up 1, the y-axis moves up 1, basically. The idea. It's going to be a perfect linear relationship, and it's going to go. The opposite is a negative linear relationship, and that's -1. 0 means no relationship. There's no relationship there. Okay. And all dots would be all over the place. Okay. And then you wouldn't be able to pick out a line. So this is kind of what it looks like. Here's a perfectly positive one. As you move a certain number of increments over, you're moving the same number of increments up. Okay, perfectly linear. In this case, there's no correlation. You couldn't draw a line through here that the dots would be close to. So this would be it's closer to a 0, and this would be closer to a 1. Okay. So I hope this helps give you kind of just a basic understanding of statistics. Didn't go much in depth, just try to give you the basic. So when you read some literature and look at some reports and get some information, that you at least have an idea what they're doing and why they're doing it, and what the numbers mean. Okay, so we'll stop here. Next class, and this will lead nicely into the next class, which we're going to talk about sports analytics. And I have a couple of videos for you to watch on sport analytics to help you kind of understand now how people in our field use statistics to help make decisions. And the analytics field is really exploding when it comes into sport. And a lot of GMs and coaches are making decisions based upon statistics and helping that in the decision-making process. So we'll stop here, and